the electrical part, we use the MATLAB and Simulink most. So I will go further in the introduction part of the MATLAB, and I will go for the Simulink block, and I will discuss a few things like what is the MATLAB and what will be the scripts, and what will be the Simulink and state flow, and what are the concepts are there in the state flow. I will use it to explain here and think about it. I mean, while I'm explaining that, I will give the example to you. And if you have not got it, please let me know. Okay. So first of all, I will go for the software like a MATLAB. So MATLAB is the software for use for the numerical computations. Like you will do the every type of like every type of calculations. So it like be a linear algebraic, or it can be quadratic equation. Any of them, you can solve the any equation in the MATLAB and Simulink. So MATLAB and Simulink is having a use this is high level programming language, so it can be done the any type of calculations. And this MATLAB is not only used for the automobile industry, it can be used for the other departments like data processing unit. We can do for the data processing unit, then we can go for the image processing unit, and we can solve the n type of numerical algebraics and linear algebraic problems by using this. Reminding thing that like what is a MATLAB means? MATLAB is a matrix laboratory. So in this MATLAB, everything will be stored as a matrix. So this is the thing why it named as a matrix laboratory. And what you think is we have a functions. This is the MATLAB is a high level programming language. I already said to you that, and MATLAB is having a high level functions. So like a sine function we have and log functions. You will get to know that when you are going for the deeper. And after that, we have a data analysis. We can go for the data analysis by using the MATLAB and signal processing. So if you give the one signal waveform, so if you write the code for the MATLAB in the Simulink, you can get the what waveform it is, what waveform it we are describing that. And optimization and data optimization means we can so in this we can go for the visualization also, 2D and 3D graphs also. If you want to imagine 3D dimension use, we have a SolidWorks or we have another topic. But in the MATLAB also that is possible to you have a 3 dimensional values, you can substitute that, and we will get the animation of 3D animations. So this is the MATLAB, and this is the matrix laboratory we have in the MATLAB and Simulink. And this is the introduction to the MATLAB. And so this is, I mean, I'm telling the environment and GAU and what is the MATLAB and how it will be look. So first we will go for the, when you open the MATLAB, you can see left side. So we have so command window, we have workspace, and we have a current file folders and mscript files. So this would be like MATLAB environment when you open that. So what does the command window do? That command window use it to write the code or execute the code. If you want to write the code, lines of code, you can write the code in command window. And the workspace use it to save the data. What you write in the code in the workspace, that will be saved in the workspace. So if you are assigning the command window a equals to 10, so that will be stored in the workspace. You can see if you write the code in command window a equals to 10, that will be stored in the workspace. Variable name is a, and value will be 10, and size will be, it will be always stored in the matrix format. If you are assigning a equals to 30, so in the matrix that will be 1 by 1 matrix, so the size will be 1 by 1. So like that it will be saved, and the workspace will be like saved like that. When it comes to the command window, if you are writing the lines of code, and workspace will be saved the all the variables. And if you want to, there is no need of writing the codes. There is no need of saving the lines of code if you are saving the data. Okay. And if your current file folders means, if you have been, you can see this is the current file folders. If you have saved your previous files, so that will be saved in the this folder, current file dictionary content and mscript files. So I will talk about next. Mscript files is also there. So one thing you need to remember that in the MATLAB we have MATLAB. So MATLAB file is saved by the .mat. And when it comes to the Simulink, so Simulink is which is a platform for the graphical environment and designing for performance. And when you have been go for visualizing the data, so we will go for the Simulink. So Simulink file will be saved as .slx. And when it comes to the mscript files, mscript file will be saved as .mat, .mlx. So this should be like extension for the every MATLAB environment. So when comes to the why I'm telling the mscript files is, so mscript files and command window same is nothing, no is there, but one thing is like, so in the command window when you executing lines of code, so we cannot have an option to edit the your lines of code. So if you are going for the live script, if you are going for the live script, or if you're going for the live project, we don't. Someone is talking with me. Yeah, you guys have any doubt, you can ask me that. Otherwise, yeah. So when you have been go for the projects, when you are going for designing a live projects, so that time when you are using command window, you don't have a writing. If you are writing the code, lines of code, if you want to edit the value of any value variables in the code, so that will not be executed. If you are going for the live project, we will go for the live script. So where it will be like, so it will be, I will show you in the MATLAB format. You can see in the, this is a MATLAB environment. So how to open the script file means, if you go for the plus and you go for the control plus n, so control plus n, you can click there, you can get the live script, or you can go for the click on this. So you will get the one window, it will open like this, and you can write the code. And some, I will execute the some of the part in the script file now, and you will get to know that how the command window and how the mscript file will be differentiated. Okay, and also you can run the script by typing the its name and command. So it will be like same as the command window, and it will be runs when you write the code. You can be execute to run this code. So you have the option after running, after executing this. So this is the best thing in scripting. And one thing is like, here is state flow. So one of the best thing in the MATLAB and Simulink is it is the same state flow. So we have I was told you that MATLAB is purely coding part, and if you want to write the code, or if you want to data analyzing, or if you want to go for visualization of data of a 2D graphs or 3D graphs, that will be helpful for the MATLAB. But when it comes to the Simulink, if you have any block, if you have any state of block, you want to visualize the data, and you want to what is the real time case will be happening in the Simulink or any block, you can go for the Simulink. When where you go for the state flow. So state flow is like a graphical environment. So you have a some step of graphs in some step of conditions we have. So based on the condition, we will execute in the Simulink. So this is within the Simulink only. So what do you do? We have a tree-like chart. We have a state flow. We have a tree-like chart. So what I'm saying here is, uh, if you take example like car, if you take example like a car, so car having what having car will be like a state will be ideal state first will be, after that will, if your driver will be give the acceleration, it will go for the driving condition. I mean it will be move, and again it was make a brake when you have, when you want to stop the vehicle, if again you will go apply the brake. So after a few seconds, after applying the brake, it will go again to the ideal condition, right? So this is the flow every time will be maintained. So we cannot option, we don't have an option these lines of what do we have a behavior we can execute in the MATLAB and Simulink. But when this is the picture is a graph, it comes in the state flow. So this you can look at that. So we have a ideal condition, we have a condition, and after that we have an acceleration condition, after that we have a braking condition, after that we are going for the again we are going for the from the braking, we are again going for the starting condition. So this is the graphical representation, and this is a visual some line of pattern will be there. So when you are going for the line of patterns, when you're going for the graphical representation, graphical environment, so you can go for the state flow, and this state flow will be you can see. So in the state flow, this application for the control systems, in the when you are going for the control system, we have a condition will be there. So in the when you take example, when I taking the example, if you have been inverter circuit is there. Inverter circuit we have a like a gates will be there. So in the gates, so it should be, I mean in the we have a six gates. We have a six gate IGBTs or MOSFETs will be there. Out of six, only two will be on, and remain will be off. So this condition will be write by ourselves in the Simulink, definitely. So this should be clear, and that should be how you write. So you can write by the Simulink also. We can go for the state flow. So you can implement the there is a graph there. If a rotor speed is like that, the rotor speed is 30 degrees. So you should be turn on one and two. You can write the code in the state flow, And after that, after the rotation, after 30 degrees rotation, it will be, you need to turn on 2 and 4. So should be like a flow and should be like a chart. So where there will be condition is there, and there will be like transition from one phase to another phase is there. So this is the way we will go for the state flow. And one thing I need to tell you that focus on more on MATLAB and Simulink and state flow. This is the good thing. And when you are going for the MATLAB, learning for the MATLAB. And this MATLAB is application. When you go for the state flow application, it will be helpful for the control system. So when you have been fault management also, in when you are going up for identify the fault in any other in charger or in ID DC converter or controller, when you're designing anything, if you have want to any fault is there, how do you find out that you can design the fault management by using state flow. And after that we have a embedded system. So in the embedded system we have a CRAN protocol. Can create the CRAN protocol in the MATLAB and Simulink. So if you want to send the message from receiver to transmitter, so you will have a flow will be there, some state of device will be there, so that should be a state flow. So this is the way I'm giving the example also how will be this will be executed. So you can see this is the states we will call as, this is the states we will call as, and this is the transition. So this is the deriving that. So this should be connected to this should be connected to this one, and again this should be connected to this one, and there will flow. I mean, what I'm saying here is, if your entry is output is 1 and exit will be 0. So if your input will be 1, so if your input will be like 1 will be your input and output will be 0. So it will be go for the so if it will check as a it will check whether is output is 0 or input is 0, either it input is 0, no. So it will go for this like. So there is a flow will be there. This is the state flow of SOC. So it will determine the whether is state flow is 100% or not. So when you charge, when you are charging, entry output will be 2 and output will be 0. So when you are discharging, output should be 3. So in between that, the value will be increment, and the value will be rotation. There is a flow between that. Every time it will check. So the condition you can see. So if a state of charge is less than or equals to 100, that will be discharge state. Whenever state of condition will be less than, of here you can see less than 100 or less than 20 or equals to less than 20 or less than 10, you need to charge the battery. So there should be a condition also there. There should be states will be there flowing on the system. And this is a thing in the state flow. We can do that. So now go to the core concepts like what is we have. I was talking more on states and transition and events and actions and data. So state means it is like a function. So if you take an example in previously, I told you that there will be like acceleration, there will be like brake, there will be like a starting condition. These are the events. These are the like states we will call as. These should be operation conditions. These should be like functions, which is like we will call as states. After that, so we will have a link with the starting ideal state to acceleration state. There will be a connection between the acceleration to ideal condition. That there will be a connection between these 2 points. We will call the transition. So this is will like represent the change from one state to another state. We will call it as the transition. So event will be occurred. So event will be condition. So if speed is greater than when it comes to the acceleration period, so when you call the acceleration, so we will use if speed will be more, so then we will call as the acceleration is more. Or if you are attending the, if you want a driver is 1 to 80 kmph in the speed in the acceleration, so this should be conditions is the events will be there. So this we will call as in the events. Action should be take as, so that should be at the point of time that should be executed. So when you are entering the state, when you are entering some signal into the system, so that should be having some condition that should be executed in within the time, and that will go for the another actions, another data. So data should be transferred, and throughout these states, data should be transferred. Therefore, without data, we cannot do anything here. So this should be like core concept: states and transitions and events and actions and data. And so this should be like I was explaining MATLAB, and I will not touch the still on Simulink. So this is the Simulink. I have done this. So this is about the speed controller PMSM by using PID controller. So you can see that I'm controlling the speed of the motor by using PID controller. When I'm taking the reference speed, or we are getting the actual speed. So how what I'm describing here is I was take the permanent synchronous motor, and after that I was in the permanent synchronous motor having a specification, some current and some voltage. After that I was take the three phase inverter circuit. So this three phase inverter circuit will be take the give the supply to the motor. So that should be converting the voltage 48 volts. I mean 48 or 300 volts or 400 volts. That will be step down or step up, that has to be converted to the AC supply into DC supply. I mean, DC supply into AC supply. So this is the inverter. Definitely, that will convert DC to AC to energize the motor. After that, what happens is there is a gate circuit is there. So in the gate circuit, we need to give the drivers there. I mean, we know. So inverter we have a three phase arm is there. Three phase arm we have a three six MOSFETs will be there in the circuit. After that we have a battery, so battery will be used to supply the motor. So by supplying the inverter, so inverter will be controlled, and inverter will give the according to the uh, speed of the motor. So if the voltage is more, definitely speed of the motor will be more. So that's why you will limit the voltage according to the speed or according to your input of the throttle. And after that we will go for the you can see, so we can go for the PID controller. The PID controller will be having a P and I and D value. So P means KP, so proportional proportional and integral derivative. So these are the three things which is having in the which is having in the motor. So the proportional will be responsible for the KP error. So directly this error will be proportional to the error. So if any error is increased, if you increase the KP value, so the error must be 0. So the faster reducing the error, we will use the KP, and the KI will be integral value. So this should be like integral of sum of all previous errors. So according to the all sum of previous error, what will be the correct method? I mean correct tuning value. So the KI value will respond for the take the previous errors, and according to that, that will decrease the error to 0. And after the KD, derivative value will be look after the any overshoot is there in the signal or any other overshoot. When you're going for the overshooting of signal, crossing the desired values of actual signals, and you KD value will come to the picture. So that will look on the stability, that will look on the overshooting of the signal. So that's the thing. And you can see there is a 1500 rpm is the reference speed which is applying from the motor, so which is applying from the throttle. So this is, you can assume that we are giving the 1500 rpm to the motor, so vehicle. So what much of speed is getting from the output? So after that we can see in the left side we have a bus selector. So bus selector we have a five signals, I mean four signals, sorry. Starter current, and after that we have a starter current A phase and B phase. So what will be like starter current when you are giving applying the voltage? You know, so when you're changing the voltage, the current, the speed will be changes according to that. So whether it is possible or not, we can look on that. And after that rotor speed, so definitely we have a rotor speed here. And after that we have a electromagnetic torque. So this is a electromagnetic torque is produced in the I mean motor. So whenever interaction of stator flux and rotor flux, so there will be electromagnetic torque will produced in the system. So after that, what happened is you can see I was making the closed loop here. So there should be a closed loop, and there is a we can see negative feedback. This was, you can see here error box is negative feedback, and you have open the closed loop circuit. And after that, whenever you're giving this reference speed or according to your value, so that will voltage will supply to the inverter. So inverter will be supplied according to the what given by the user. So that will give the energy to the motor, and motor will be rotate. So the rotor speed is again fed back to the so the rotor speed will be again fed back to the error block. So in the error block we have a reference speed and we have actual speed. Based on these two error, the PID controller will be controlling the KP value or KI value or KD value according to the error we have getting, margin of error we have getting. So the voltage source will be triggered and will be work. So this is the about the speed controller PMSM motor, and I will be executing the MATLAB and Simulink, and you can get to know that how will we work. Yeah, till now, you guys have figured out. I mean, someone is, you guys have figured out. You can ask me that. Join. Yeah, you guys had any doubt, and you can ask me that. If I'm not, I will proceeding to a MATLAB file. Wait a minute, I was opening the file of the MATLAB, and yeah, I think. What is the PID values? That what does it is, sir? What does it mean by PID? PID is a controller. So proportional integral derivative. This is a controller which will control the speed of the motor or speed of the motor. So when you are changing the, there will be gains will be there. We have a three gains will be there. So this gain will be response for the reducing error. So we have what we mean by reducing error means we have a reference speed and actual speed is there. So we know reference speed is motor. Reference speed is throttle and actual speed is motor. So it should be equal. So definitely it should be equal. Sir, can I use a drive cycle in the place of reference speed? Definitely you can use that. That is a good. You can use that also, and that you need to convert that drive cycle speed into. I mean that will be a velocity. So you will, that will be a velocity. You will need to convert the RPM because the motor will be converting the RPM to. So there should be the quantity of the reference speed and actual speed must be there. I know. Yeah, is my screen is visible to you? Wait a minute. I mean, it's opening. Yeah, and also someone is asking me questions like you can use a drive cycle because drive cycle will be in the I mean velocity meter per second. So you need to convert into RPM meter per second into RPM. So then you need to give that. And someone is asking that can you explain the PID conversion functions? So I was also explained here only conversion functions only how with the KP and K and KID values. You will get to know the how the it will work. So this is a Simulink, which is like go for the Simulink, and this is the MATLAB environment. So in the MATLAB environment, we have a. I already said to you that this is a command window, and this should be. So I was open the MATLAB online, and you can install the on your PC. This is everything two are okay, and you can see this is the command window, and this is the files which is having done before, and this is the workspace. If you write a lines of code here, that will be execute, that will be saved here. If I saving, if I entering the a equals to some value, and that will be execute, that will be stored in the value. If I entering in the matrix format, if I entering in the matrix format, so you can see the size of the matrix will be 1:2. So one row and two columns will be there. So you can see I've already told you that the matrix will be saved the variables in the form of matrix. And you can open the live script. You can click here. So this is the live script. You can go for the when you are going for the live projects, or when you are designing the when you want to write the lines of code, anything. So you can write here. So a equals to 15, anything you can write here. And you can go for the you can, when you are clicking the live editor, we can go for the live when you're clicking the loop script, you will go for the live editor. So in the live editor we have this environment. So we have a section break, we have a session run. And the session break, wow, will be helping that you have a so if you are calculating the tractive force of any vehicle or anything, or a kinetic energy or potential energy, if you are calculating total energy of the vehicle, the kinetic energy and potential are two different. So you will one section will be potential energy, one section will be kinetic energy, and total, I mean third section will be total energy. Like that you will divide the according to your project. And this should be like, you can run this. You can see the value store here. Okay, I saw in the video, I mean, I saw the graph in the simulation. I was in the PPT, I was shown the PPT, how the speed control, PID control will be there. Someone is speaking something, like you can ask me doubt, or you can otherwise please close your mic. Yeah, first is like first of all we will go for the motor. So in the Simulink, we will go. You can access the libraries. You can have a number of blocks will be there. So you should be know what block you need to use. So here I am going to control the. I'm doing the speed control of the motor. Sorry, speed control of PMS of motor by using PID controller. So PID controller. So this should be our this should be our title of this project. Okay, fine. And after that we need to go for, first we will start with the motor. So after that we will go for the inverter. After we will go for the battery. So I will go for the PMS motor. So permanent magnet synchronous motor, that will be. So you can see the permanent synchronous machine is there. So I imported this one. So you can see this is a mission. This is a motor, not a motor, or this is not a generator. Mission means it will be like motor or it will be generator, any of them. So we will be identify the whether it is motor or generator. So when you are imported any block in the Simulink, you should be must to know that what is the block about that, what the block is features about that, what will be the input ports and what will be the output ports. So when you are going for this one, so we have a three phase inputs. We have ABC. So that should be motor, you require the voltage, and that will be generate the whether that will be generate the rotor rotations, output rotation. So we can take the output from the M, and we will give the input as a from the ABC, and that should be like TM will be there, input torque. So this is the mechanical input. So you should, this is the initial torque we need to apply the motor when you need to turn on, when you need to rotate the motor. So when I double click there, so I was getting this one. This is the three phase system, three phase wires, and this will be back EMI will be sinusoidal. You know, The trapezoidal back EMF is equal to the BLDC motor. So if you are going for the BLDC motor, you can go for the trapezoidal. So if you are going for the PMSM motor, you can go for the sinusoidal. Okay, and you should be round. Round should be a rotor, and input torque. So mechanical input you should be give the mechanical input. So I mean when you are starting the motor, we require some initial torque will be there. So that should be applied by your vehicle. And after that present model, so you can see you can take any of the model you can as a reference. So you can go for the 20 newtons 300 volts 220 2200 rpm, or you can go for the any of them. So I'm going to choose like 20 newtons 300 volts 2200 rpm will be highest, and 33.9 will be like peak torque. So okay, I'm selecting this one and you'll be applying it. So if you want to study more on this parameter of this PMSM, so you can go for the help, and in the help you will get the details of the motor, details of the block, what it is mean. So what will be how you derive the ID current, how do you derive the electromagnetic torque. So equation will be there and must be there will be references will be there in the system. Okay, and this should be there. So you can see what are the inputs we need to revive. So that were TM and omega, mission speed. So I already said to you that so this mission is like we can use this block as a generator. We can use this block as a motor. So when you are supplying the positive value of a TM, so that will act as a motor. When you are supplying the negative torque to the TM, that will act as a generator. Why it will be you can see this block details the mechanical shaft, mechanical torque of the machine shaft. So the input should be normally positive because the permanent minus synchronous machine block use it as a motor. If it is positive, use it as a motor. If not, it will use it as a negative torque will be like generator mode. Okay, so that's why in also positive value will be applied there. And yeah, this should be you study by yourself, and if you want to know more about that. Okay, I'm just applying it, and after that I will go for the bus selector. So I will need to select the outputs what are required for that. Okay, so double click on the bus selector there, and you can select the signal, what signals you need to require. So I required rotor speed, definitely that will be required. Based on the rotor speed we will control this things. So rotor speed I required, so click on there and add it, and rotor angle and electromagnetic torque, and what is the stator current will be there, what is the stator current will be there at present. So this should be enough. You can take or you can take any of them more, increase the size. Yeah, so we take the scope. So how many inputs we have? Well, 4 inputs we have, but in scope we can, by using scope, what is the scope we use? Scope for the if you have any value changes with respect to time, you can see in the scope. If you have any type of value, you can know the how value will be changed with respect to time. So you can go for the scope. I need to know with respect to time how the voltage and how the rotor speed and how the electromagnetic torque it is producing. So I want to know that. That's why I'm using scope here. So double click on there. I need to increase the 4 inputs here because that will be 4. Yeah, 4 should be more. Go for the number of inputs and 4. Make the 4 this one, and layout. Go for the layout, and layout should be 4 by 4, not 1:1. 4:1, 4 rows with 1 column. So that should be display like this, 4 things, and apply it. Yeah, and attach to this one. Okay. Yeah. So we need to give the ABC values, that will be inverter, and you need to take the first battery source. So control voltage source I'm taking here. So I know the blocks, that's why I'm directly taking here. But if you have been doing, you need to know the which block used to use. That should be a thing will becomes when you are doing more practice on the MATLAB and Simulink. And there should be inverter bridge, so that will act as an inverter. And so this is the inverter circuit and this is the battery, and we need to arrange this one. So I need to flip, I need to these things with the left side and this should be right side. Do control plus I. You can see the block is flipped. The block is flipped to left side to right side, and this should be connected to the positive, and this should be connected to the negative, and these three are connected to the positive of the A phase to A, and B phase to B, and C phase to C, and the gate supply and TM will be required. So TM will be like constant torque, I mean mechanical torque which is required. So take the constant, and that should be a positive value only. So I am taking only one, because if I indicate the positive value, it will be act as a motor. If not, it will be act as generator. That's why I'm implementing is like. Yeah, yeah. So after that, I need to give the gate pulses. So I go for the subsystem. So the gates are here is these are six things are there. We have six switches will be there. For six switches, I need to generating the PWM signal for each of them, and that we should be connected to the gate supply. So for six switches, I am taking PWM generator for six. PWM generator, pulse generator. Sorry, the pulse generator we need required because six will be required. Six will be one is to be connected to the uh, one of the gate. I mean, for every each MOSFET, one pulse will be connected to that. One pulse generator will be connected to that. So that's why I'm taking six. If you are the same block, we need to go for control plus V, control plus C, and control plus V. I am going for six. Yeah, and this has to be converted. Six has to be converted one input only. Gate this we are converting these all six signals to the one, and input should be six and output should be one. So mux will be like getting the number of input more and getting output should be one. Mux. Yeah. So this mux because why I'm taking this, because we have, you can say the gate signal is only one. So it should be directly connected to the six only, but for the input side only we need it. We are connecting only one, but it will be considering only six only. Not like that. It will considering only one. Six input. Yeah, one should be connected to this one, and second, and third, fourth, and this should be fifth. This should be sixth. And current output this one, and this output has to connect it to this thing. So this is our subsystem and place here, and this should be connected to the gate supply. Okay, and now you connected everything and you have fine, but now you need to convert connect it to the PID controller and close the loop to control the speed of the motor. So if I need to convert PID controller, I need to take, so PID controller has to be there. And after that we need required error block here. So we don't have error block direct, we need to take the sum, and you need to make the sum as a plus plus to minus minus, because this is the negative feedback feedback is, this is not a positive feedback, so that's why you need to go for the positive and negative, and this should be there. Yes. And after that we have reference speed. So this is to be connected to the controlling voltage, and we have a reference speed. We need to go for the constant and apply the reference speed there. So I'm here applying the as a taking the constant value. Don't want to take the constant value. You can go for the drive cycle also if you want, or you can go for that also. But before that, you need to convert into the RPM. I'm applying 1500 RPM is my reference speed, and I required is like here is a required motor output. I hope you are saying this thing. Yes. So I have a rotor speed. So I need to require rotor speed to the PID controller error block, because of these errors only PID will be triggered. So what you do is like I need to convert this speed is the speed of our rotor speed into radian per second into RPM, because it should be like radian per second. So we are giving the RPM, which should be radian per second. We need to convert into the RPM. So the by converting factor will be there, omega equals to omega into RPM. So I need to do that, and then after I will connect it. So this should be a connect directly this one, but we should be RPM and this should be RPM. Same quantity will be there. If not, you will get the error. Gain and go for control plus R. Yeah, this should be connected to this one. This should be connected to this, and this should be factor is 30 by pi. 30 by 5 the factor for the converting the RPM into converting radian per second into RPM. You can check on that also whether it is correct or not. And yes, if you need to check whether it is speed getting accurate or not, and we need to keep the display here. Display. So keep the display here. Yeah, and yeah, everything is connected, and I need to go for the run. This should be 5 seconds. Yeah, why I did a mistake, because when you are going for the electrical system, we need to go for the continuous power guy is there. For without power guy, the electrical system will not work. So that's why you need to go for the power guy. It should be negative because uh, the rotor is we have conversion pattern problem is there, so the sign will be negative and error is getting here. So give the minus value here, and we didn't get the accurate speed. We are getting 1500 rpm, but you are not getting speed. Because why you are getting this one? Because the solution is, I know, here is what happens is, when you're converting AC into DC supply, we need to use, you can go for the universal bridge. So we are using thyristor. So thyristor will not be support that much of power. Definitely it will be possible, not possible. And that should be like MOSFETs and IGBTs are used for inverter circuit. So you can use this both of them, any of them. You can go for IGBTs or you can go for the MOSFETs. But if you are going for the thyristors, that will not be works. You can see. Yeah, you are giving 1500 rpm as a reference speed, and you are getting 1572 rpm. You know your conversion is the 1500 rpm, but you are getting 15.27. Why it is happening? Why it is getting more speed? And you want to see the graphical with reference speed and actual speed scope. Because why I'm saying here is, you can get to know so how the reference speed will play and actual speed will play, how the reference speed will be reached by the motor in the waveforms when you change the PID controller. So that's why I'm here placing the two things to scope here, two, and this should be connected here, and this should be connected to the actual speed, and you can get to know how the speed will be changes. When you're running this, uh, you can see the scope. You can see the scope here, which is like we have a desired speed is 1500 rpm, but actual speed is attaining the 1500 15 above the 1500 rpm, but it's taking some time. So it was taking like for 1500 rpm to reach 1500 above rpm, it was taking 4 seconds to reach 1527 rpm. So we know in the control system we will study like we will study rise time, we will study the overshoot, we will study the settling time. So that should be in the graph, you will know that. So like we have 0.5 to 1.2 will be like rise time, and this should be like overshoot time. So you can see the overshoot. This is because this is over the desired speed we are getting here, and you can see after some time the speed is reducing and getting the stability is getting there. So this should be happening here. Simulation, when you open this one. Yeah. So what happening here is, I was changing the PID value. So whether his speed is changing or not, you can check on that. So I was always talking about whether changing the P or whether changing these things, it will be happen. So if I change the P values and KP value and KD values, so changing these errors, changing these gains, so error will be that will affect on the errors. So the PI controller should be, the controller aim should be like decreasing the error of the signal. If error is more, the fault signal will be happen. I mean, fault or negative impact will be done when you are being uh, error is there. So if you are decreasing error, you will system will be more stable and more controllable, definitely. So I'm increasing the KP values to be 1 and integral value is 0 and derivative has to be 0. And what will be done? Apply it and run it. You can see the 1300 rpm we are getting, but it is not overshooting, but we are getting only 39 RPM. It is stable. So it was taking like you can see that it was taking 1 second, 1 second to the stable the signal. But it was reaching the one signal to 13 RPM, and after that it will be stable, and it will not reaching to that desired speed. The KP value is one, it is not reaching the KP value. KP value is one, it is not designed to desired speed. It was stuck with the 1332 because there should be KI value should be also taking the factory. If you are increasing KI and KP value approximately and correctly your value, then only you will get the your controller will be reach the accurate speed. So this should be your KP and KP value will be balances. And if you are opening the scope of this thing, you can see electromagnetic torque and rotor speed and stator current and this thing. And you can see this is the radian per second. You can observe that this is the radian per second. This is the angle, rotor angle, and this is the electromagnetic torque. You can see all these waveforms. If I increase the scope, if I can see this, yeah, because of this screen, this is fitted. If you have been opening for the MATLAB in PC, it will be looking great, and you can see the waveforms, the sinusoidal will be coming out here. So this is about the PID control installation, and I was derive the circuit in the MATLAB also. You guys are having any doubts regarding this? When I anything about that, I can answer your questions. If feel free to ask to me. If are any guys or any, you can ask me that, how you can
Hello.
decide the block which is it to choose. So that
Hello.
really has to be if you want to learn the software. Yeah, someone is asking something. Yeah,
Yeah, sir. Good afternoon, sir. Actually, I have one doubt related to that PID controller.
yeah,
Uh, you just change the value of KP, KD, and that KI, right? After
yes.
that, you see the speed is decrease, whatever. If I want to optimize that value, okay, my own algorithm, like anything like a GA or PSO, any algorithm I want to input in that PID block. Is that possible?
Yeah, definitely. I can I can get the 1500 RPM and output as uh, I can get the zero error by using PID controller. So if I apply the 1500 RPM, I will get the output as 1500 RPM only. I can get that. If you are much more about the PID values, so what should be PD value, P and KP and KD value, you can do that. So the range between KI should be one every time because KI should be response for your error. So if error will be, if I take example, if error 15 RPM is your reference speed and your 39 RPM your is output speed. So there should be, if you are comparing these two, 15 and 39 RPM, there should be 200 will be your error. So what if here is after that 200 error will go for PID value. So PID what does do? So the PID is like whether according to the error, according to 200 error, what should be the gain should be there. So the KP will be response for the if a more error will be there, the KP will be comes to the picture and KP will be changes according to the zero point 0.8 or 0.1 or I mean 0.8 to 1. If you want to get your desired speed matches desired speed with your actual speed, your KP should be always one, and your KD value, I mean KI value should be like 0.1 to 0.5. So this should be value will be there, and I'm telling this value, but if you are the research guy, you can go to the for the research more, and why you are getting negative rotor speed. So because one thing I need to confirm this, and because like if you are to go for the trial and error method in the Simulink block, you can get the what value is suitable for that. So this is the thing I need to tell you that. I hope you are gained that.
Okay, my question is like that if I want to apply one algorithm in that inbuilt work, is that possible? Like any algorithm, is that possible for
What
tuning purpose?
what algorithm you want to implement there?
Like genetic algorithm, I want to apply in that inbuilt box. Like in that Simulink, I want to
Yeah,
apply.
you need to use the state flow here. So when you are implementing the so in the MATLAB we have two things there, ma'am. So one should be like mathematical model, one should be like block model. So I was implemented here is block model. So if you want to go for the any algorithms or anyone, you have a mathematical equation is there. If you have a equations of that, you can go for that also. So
Yeah.
this is the thing you can do that. Yeah.
Yeah, but it's possible not to apply in Simulink, like coding apply in Simulink
Yeah, it's applied.
interface.
Yeah, it's applied. It's applied. That will be. This is the webinar. We have here all these things in my portal, so you can contact in my portal also. You can go for the IS in the website. We will get there. It will possible, ma'am. If you want to go for the mathematical model also, you can do that. So yeah, and also you mentioned that get trigger process. I know didn't mention everything here because this is a basic introduction I was given here how to do that. And why you are getting negative rotor speed, because when I was like when didn't apply the inverter circuit as a rotor, I mean inverter circuit as a IGBT some MOSFET, I will get the negative because the thyristor will not be sustain that much of voltage, that much of current do that. Definitely, no. You can observe that I didn't do anything. So if I inverter circuit will be thyristors, if I invest in thyristor diodes, so it will not be run because that thyristor cannot be capable of that much of power, handling of that much of power and current. So you can see the current will be varies or the current will be increases, the current will be decreases, it will be done. So this is the thing will be happen there. You need to go for the MOSFETs and thyristor because they are capable of high currents and also they are capable for high switching frequency. And yeah, something you have getting, can you get the recording video? Yeah, you will get there. You will as the certificate and also. Yeah, and other guys, I mean, any have any other doubts? Yeah, if you have any question you can ask me that. If you not, I
If you guys have any doubt, you can ask from the expert. I hope everyone has learned this session. If you have any doubt, you can ask from the expert. As we are winding up this session, if you have any doubt, please ask right now. If you guys has any doubt regarding the courses, you can scan this QR code and our executive will contact you shortly. I hope everyone has learned very much from this session. If you don't have any doubt, you can leave this session, and either if you have any want to purchase a course from the ISI India, you can scan this QR code and then fill the form. Thank you very much for joining this session. And the certificate will be shared on Monday through your registered email ID. So please have a look at your email inbox. The mail can also be in spam. Thank you for joining the session.
Thank you, sir.